Hey, Steven here from TechMaker.tv. This is part 3 of the Building a Blockchain Integrated Web Application series. In the last episode, we essentially finished our voter registration contract, and in this episode, we're going to keep moving forward and we're going to develop out the votable issue contract, as I'm calling it. Essentially, what that's going to be is a smart contract that's going to keep track of what issues we're going to vote on, and it's going to run validation and make sure like you're actually registered and that sort of thing. A particularly interesting point of today's discussion is the fact that this will be the first time we've looked at how to integrate two different smart contracts with each other. It's not that different than using a class inside of another class in object-oriented programming, but it's a little bit bizarre for some people when they first see it. So anyway, we're going to tackle that here. All right, so let's jump in. So to get started, we're going to set up a new test. And inside of our test directory, we'll create a new file called votableissue.js. And we will basically do exactly what we did in the first episode here. Let me close that out because I don't need it. And we'll say votable issue and votable issue.sol, and this should cause our test to fail just from the start, which is essentially the same process we followed in episode 1, as I said a minute ago. So when I'm developing and when I'm doing smart contracts in particular, I try to follow the TDD paradigm of development as much as I can. So this may be a little bit obnoxious to some people, but I wrote one line of code which all it's doing is trying to require something and it's breaking my test. And so I actually think that's a very good point to stop testing and like actually fix some stuff. So what we need to do, according to the error we're getting, is it can't find the artifact votable issue.sol. So we will now create that contract. And we'll run it again. And we get could not find votable issue. So let's see, make sure I remember what, I don't need this open file stuff. Let's make sure I remember which version of Solidity we're using. So we'll grab this. Nope, not that. Paste that there. Contract votable issue. Save that. Let's close out the file tree again. Should be done with the file tree for now. Run this, and this should not be broken anymore. Okay, so back in our test, we're going to keep going. So we're going to say contract votable issue async accounts fat arrow function, like that. Okay, so our first test is going to be extremely simple. We're going to say it gets created with a let's see, what do we call this? Like a voting issue code. I don't particularly love that. See if we can think of something better in a second. But basically what I want to happen is whenever we create a contract, it needs to have some kind of like legal code, like 39R or something like that. Like this is issue 39R. And part of the reason for that is like, you hear that on TV and whatever when people debate particular legal, changes that are being suggested. But also as a way to reference a larger document that's not going to be stored on chain. You don't want to put everything on the blockchain. I know that may be controversial to some people, but you don't want to put large amounts of text into your smart contract because there's all this stuff about it being immutable and stuff, but it's really just not that practical at the moment. So I forgot to make this also async right here. So I should do that. And then I should make that sync tactically accurate. So the first thing that we want to do here is just say let, what do we want to call this? Issue equal votable issue dot new, and we're just gonna give it, I guess we'll say, like I was saying, I'm gonna go like 39R, and we need to await this, and let's run our test again. Okay, so we're still green, so let's go ahead and throw an assertion in here. So we'll say assert equal issue dot code 39R, and then we'll say issue code should be 39R. So you can see this is a pretty simple test that we're running here, and the solution is going to be really easy, but that's okay. That's the way we're doing this. So we're going to jump over into votable issue, and so it's saying expected undefined equal 39R. So first thing we need to do is we're going to say bytes 3 public code. Okay, so this basically says we're allowed to have a string of 3 characters long for this thing we're calling code. Okay. Now we're going to write our constructor, which, as we saw in the previous episode, is written like this. So we're going to say constructor. We'll say bytes 3 code, and we'll say public, and then all we need to do is say code equals code, and that should get us passing. Okay, so it did not pass, and we have this assertion error issue code should be 39R, which is what we wrote. Expected function equal 39R. So there's a couple of things going on here, actually. So what I'm going to do is split this up and say let code equal await issue.code.call. So that's actually going to go out to the contract and get the code and give it back to us. So now we should just be able to say code here. And this is probably still going to fail for another reason, actually, that I had forgotten about. Okay, so now we get this. So what we need to do, actually, is call something called web3 to ASCII, I believe is what it is. So now we're all green. So basically what you have to know is that this is how things get stored on the blockchain, and we have to convert it back into something human readable. So in order to speed this up a little bit, because I'm realizing this is going a little slow, I'm going to kind of jump into something a little more complicated that's going to help us sort of tease this out a little faster. So I'm going to say it allows registered voters to vote. And we're simultaneously going to put it does not allow unregistered voters to vote. Okay, so the first thing I'm going to do is jump back into my voter registration tests. I'm going to grab this. We're going to throw this here. Okay, now we're going to copy this, put it here, and pass in voter registration. And let's run the test and see if that gives us any trouble as it is. And while that's running, I'm going to keep moving over here. Okay, so the first thing I want to do to this is basically say, oh, nope, it totally broke. Let's see here. So let's look at our test up here again. Let's require this. So we need to make sure that we require that artifact. Let's see if that passes now. I'm going to get myself in trouble trying to go too fast. Okay, so we're all green. Okay, so now let's say let voter equal accounts, and let's just grab somebody, 6. Okay, and then we need to say voter registration. Make sure I remember the function. So we did this over here. Await voter registration dot register. So we'll say await voter registration dot register voter. And actually, I'm going to kick this up here before we set up the issue. That might be something to test, is like, does that sequence matter? I'm actually not sure, so I'm going to do it the way that I know will work. Okay, now we should be able to say issue dot vote, and we'll just give it like I don't know, should we make it a string like yes or no, or should we make it like a boolean? For now, let's just make it a boolean, and we'll come back to it, and then we'll say from voter. Let's run this, because I think we're going to have stuff broken all over the place. Okay, so the first thing is issue.vote is not a function. So we can fix that. We'll jump into votable issue. We'll say function vote. That's it. Let's see what this does. Okay, so we have a bunch of stuff screwed up. Invalid arguments to solidity function. Okay, so what is the argument? So we have a boolean, and we'll just call this vote, and then let's just say that's what it is. So I'm getting some warnings, but my tests are all actually passing, which to me is a little interesting because we have a lot of code here that seems kind of screwy to me. But let's go ahead and check basically a value which is going to force us to write the rest of the code. Okay, so here's what I'm going to do. So let's say let's vote cast equal await issue dot vote from let's say, I think we have to say dot call because we're going to be reading, and then we'll say voter, right? So we're going to basically pass in the address for this voter and try to get back their vote, and then we'll say assert equal, and it should be vote cast true, voter should have voted true. Something like that. Now let's run this and see what happens. Okay, cannot read property call of undefined, so we expected that. So let's check this. Let's say, what do we call that? vote from. So we'll say function vote from address voter. And I'm leaving all this up blank on purpose because I want the test to basically tell me what to do. And I kind of find some of the way this behaves a little bit strange personally. Okay, voter should have voted true. Expected empty array to equal true. Okay, so I think we can start writing some code now to make this actually work. Okay, so I'm gonna just start fleshing this out and we'll see what happens. So I know that I need to return, so first of all, public returns Boolean. Okay, so now what I wanna do is return the, let's say votes and then voter. So now if I run the test again, I'm going to get another error saying like votes doesn't exist or something to that effect. Yeah, okay, so votes doesn't exist. So the next thing I'm going to do is say mapping address. Let's see, what's the syntax for this if I can remember off the top of my head. Address Boolean, and it's going to be votes, and we're going to make that public. And we'll see what that does. Okay, expected false to equal true. Okay, so this is interesting, and it's giving you a little bit of information here. So it's false by default. So that's good to know. Okay, so now what we can do is say, and actually that's a little bit interesting of a problem. Because if we think about that, what that means is that if I have a list of registered voters and I just say simply like, okay, let's check what all those people voted. If people didn't vote, that's going to come back false by default. So let me make a little note about that. Returns false by default. How to count votes. So that's probably going to be an issue for the next episode where we work out exactly the strategy there. Okay, so for now, let's ignore that. And what we're going to do is say we need to basically make the vote function work. So I'm going to say votes message.sender equals vote. Okay, so, and what that's basically doing is, because we're running this function here from that voter, they're the message.sender. So let's run this and let's see what happens. Okay, so we're green again. So while we're here, these warnings are annoying me, and I'm ignoring them. So I'm going to go ahead and just fix that. Okay, so vote should be public. Function state mutability on vote from can be restricted to view. So let's just do that, and let's run the test again. Shouldn't change anything except for hopefully the warnings go away. So if you'll notice back over here, all right, looks like the warnings are gone. Okay, cool. So if you notice back over here, we're not really taking the voter registration into account at all yet, and all of our tests are passing. I find it really odd that this constructor function doesn't blow up when it has the wrong number of arguments. So we gave it a voter registration, and it only actually expects one argument. So I find that very weird, personally, because the other functions do blow up if you give them the wrong number of arguments. That aside, let's go ahead and implement this function. And so I'm going to just grab everything here, and we'll refactor this in a minute. But let's change this guy to voter 9. Let's don't register him. And let's say that, let's make sure that I remember how to do this. Okay, so we need to try, catch, error. Okay, so let's go ahead and, so we're gonna have the voter vote true again. Okay, so I can bump that up there, and I'm gonna say try to vote, catch, error, and I'm gonna expect this to be false. Voter should not have been allowed to vote. Now, I will go ahead and admit this is a little screwy, and we're going to have to work this out probably in the next episode about what should actually be happening here, because we don't want that to register as a false vote. So like I said, we're going to have to look at the way that we actually want to tally votes. But essentially, if we're checking an address and there is no answer, it's going to come back false. So we can say, like, if he tries to vote true, and then we check that his vote, we check his vote and it comes back false, so we know he was not allowed to. So let's run this. And actually, I'm going to bump this outside of that, because that's just going to, I'm going to await this. And I should be awaiting it here, actually. And that should do the trick. Let's see what happens. Okay, so now we have a failing test where we're expecting true to equal false. So now we actually have to implement our voter registration. Okay, so the first thing I'm going to have to do is jump up here, and under version we'll say import voter registration.sll. And then down here in our list of variables that we're declaring, we're going to say voter registration public, actually I got that backwards, so voter registration public voter registration. So the way this actually is going to work is that the voter registration contract code is going to be loaded via this import. But the way that you have to remember that the blockchain works is you have to actually deploy contracts. So you deploy a specific set of code to an address on the network. So you can have different, it's like a class basically. So you can have a class and then you have an instance of a class. So you have an instance of your contract that lives at a certain address. And so actually we can do something, and this may actually be why this is failing. Let me try something here. So we can say, first of all, let's just do console.log voter registration.address. Let's do that, and let's just check out what we've got here. So once we see that, what you'll basically see is that this deployed voter registration it's an instance of the voter registration. It's not, the class itself, it's an instance. So let's grab this. Actually, I can just write it .address right here. And I'm wondering if maybe that's going to cause this to blow up, because maybe it doesn't know what the other thing was, so it just ignored it. I'm not sure. Let's see if this changes anything. Okay, cool. So that's actually more in line with what I expected. So, okay, so what we need to do in our constructor then, so over here, just to read it out, we got a expected one argument, receive 2. So we're going to define this as voter registration address. Okay, so now what we need to do is say voter registration. So we're setting this variable because right now when we launch the contract initially, this is going to be blank. So what we're going to do is say voter registration equals voter registration, and then we're going to wrap the voter registration address. So let's run the contract and let's just make sure we don't get any errors. Run the test rather. Votable issue constructor. Expected 2 arguments, received 1. Oh, okay, I know what happened. So now we're getting the inverse, right? So now we have at the top, we have this, right? And now we need to say voter registration dot address. Okay, that's good. Consistent everywhere now. Should be. Okay, so now we still have our expected true to be false, but everything else seems to be flowing smoothly. So before we keep going, we can actually do something now that we have this in every single one of our tests. We can say before async, and this is going to execute for every single test. So like, for example, we could bump that there, and I don't need it here, and I don't need it here, and that's going to simplify things a bit. Let's just make sure that I'm not wrong or misspelled something or whatever. So basically we should get the same deal, and voter registration is expected true to equal false. Okay, same thing. Cool, so let's jump back over here into our votable issue and let's fix our problem. So the first thing I wanted to just say is that what's happening here when I made the comment that this is wrapping the address, basically what it's doing is it's saying like, okay, we load up the code, but this is essentially getting the instance that lives at this address. Okay, so the next thing we need to do is pretty simple at this point. So what we can do is say require, let's see here, what's the method that we're using? Is registered. So what we're going to do is say require voter registration dot is registered message dot sender. Okay, let's run the test and see what happens. And we are passing everywhere. So I think that's about it for this episode. In the next episode, we'll work out a bunch of sort of business logic issues that still remain for the voting system, smart contracts here. Once we do that, that'll probably be one more episode, hopefully just one. And then we will dive into integrating into the web. So I hope you're excited about that, and I hope you're finding this useful and helpful, and I will talk to you next time.